Hello everyone. Today I would like to start new concept work and energy. So what do we know about work? So observe these pictures randomly and ask a question. That question is, how do you define work? So let me ask you some question. Observe the picture. Are they doing any work? Yeah, they are the planting paddy. Yeah, they are doing work. In general, we say that. Yeah, they are doing work. See so many workers in the factory. They are sitting and they are doing their work. Yeah, in general context, we say that they are doing work. And in the office, are they doing work? Yeah, obviously they are doing work. So that's what we define work. And oh, this is a very big work. Right now, what we are doing. So this is the biggest work for us. Yeah, studying. Studying is also a kind of work. We need to apply so much mental stress on writing, reading. These all comes under the work, what we know it. But think about this. Now, whatever I show, the pictures, you observe them very carefully. Now asking a question. Is he doing work? So the muscle man, he is pushing a rock. Is he doing the work? Yeah, he is doing the work. As per our knowledge, he is doing the work. And is she doing work? She is climbing the staircase. Is she doing work? Yeah. Maybe she is doing work, or may not be she is doing work. Think about it. Yeah, coming to it here. Are they doing work? They're playing basketball. Are they doing work? And finally, this little girl, she is pushing a cart. Is she doing work? Yeah, there are the two ways to define work. So these all are the examples what we are discussing. So these are the general examples of to do something. So planting and working in the factory and working in the office and studying. So these all we say that, yeah, in general context we say that. So these all different kind of work. But according to physics, we define work. Oh, mostly I forgot to give this example. So his person is carrying heavy load. Is he doing work? Yeah, in general context we say that he is doing work. But in physics, we define work. The work involves effort and accomplishment. So we define in physics work as the product of force and displacement. So to define work, we need to apply certain force, then that object should displace. Then only we say the work has been done. The work formula we can give that the work equal to force multiplies displacement. So we can represent that in a formula manner, F bar dot D bar. Here F bar is a vector, force is a vector, and displacement is also vector. If we multiply, here the dot gives multiplication. If we multiply force with the displacement, then that we define as work in scientific manner. So let us think about it. The force and displacement should have in the same direction. When we apply a force on an object and that object should displace, then only we say that the work has been done on the object. Now let us give the units of work. Work is nothing but the product of force times displacement, force multiplied with displacement. Force unit is Newton and displacement units are meters, and we can write Newton as kg meter per second square times meters. So if you can multiply everything, kg meter square per second square. So we can say finally altogether the work units are joules. Remember here, the work units are joules. So these are the units for work. Now think about this example. How much work will this boy doing in 3 hours? Here you can observe a small boy is trying to apply force on this rock. He is applying a force which is given at here 250 newtons. So if 250 newtons is the force applied on the rock, how much work he is doing? So the work formula goes to force times distance, displacement. So here the rock is not moving. If the rock is not moving, so therefore the displacement, here is supposed to displacement. So the displacement goes to 0. Now if you can multiply 250 with 0, you can get 0 joules. So it means this boy is not doing any work. So the work done by the boy. So we can define work with force times displacement. The force is applying in this direction on the rock. So this is the direction of force. So the force is given 250 newtons. But the displacement, the rock is not displacing. The rock is at rest. If the rock is at rest, what is the displacement? Displacement is 0. So there is no displacement. If there is no displacement, the boy is not doing any work. So we can define that at here no work. So the boy is not doing any work because at here displacement is 0. So try to apply the same conditions at here. Now what the question I am asking, is he doing work? Yeah. If he is applying a force along in this direction, if the force applied in this direction, if the rock is moving in the same direction, if rock is also moving in the same direction, we can define work equal to force times displacement, F dot S. So he is doing work. So he is doing work. Now let us understand this example. Now she is climbing a staircase. So here there is no another object. So she herself is doing. Now is she doing work? So to define work we need two things. One is force and one is displacement. Force, another one is displacement. So if you can take her displacement in the forward direction, yeah, to climb the staircase she need to apply some force. So in this case also she is doing work. To define work, force should be act and displacement should be there. Now, are they doing work? Yeah, obviously they are doing work. They are applying force, push and pull, and they are displacing one point to another point. Yeah, they are defining, they are doing work. And if she is doing work, yes, she is applying a force on the cart. Let the force on the cart in this direction, the cart also moving in the same direction. So this is force and this is displacement. So we define work equal to the product of force times displacement. And these two are in the same direction. So we can say she is doing work. In scientifically, we can say that she is doing work. So finally, is he doing work? Is he doing work? So this is little tough to explain right now. So where is the force direction? The force applied by him on the weight. So he is applying force in this direction, upward direction. And where is the displacement direction? He is moving forward. So this is the displacement direction. Now force direction and displacement direction, they both are not in the same direction. So force and displacement is not in the same direction. If force and displacement is not in the same direction, we say that the work equal to 0. So scientifically we can say that he is not doing any work, because the force applied by him, the whole weight is on his head, so his head is also has to apply force backward. So the force is applied by him on the weight is upward direction, but he is moving forward direction. So displacement is forward direction and force is upward direction. So they both are at an angle of the 90 degree. So in this case we define that the work is 0. So this is something unacceptable in this case. But according to physics, we can say he is not doing any kind of work. So remember it here, the work formula force times displacement. In formula manner we can write F bar dot D bar. So here F and D, so these two are vectors. Vectors are having magnitude and direction. So whenever we calculate work, so we need to more careful about directions. So let us understand this. And more very important at here, the force and displacement have to be in the same direction. If force and displacement they are not in the same direction, we cannot accept that work has been done. Let us try to understand with that with an example. Suppose this is a forklift, so it is displaced 6 meters. And how much work done by this forklift? Forklift means a vehicle which used to lift the weights. You use this formula, work equal to force times displacement. Here the displacement is given 6 meters and force is also given 10 Newton. Now calculate the work. So use the work formula, work equal to product of force times displacement. So here the work done by the forklift equal to 0. The work done equal to 0. Why? Because here the force direction and displacement direction, they both are not in the same direction. Here force direction is upward direction and displacement is acting with an angle of 90 degree. So this is force direction, this is displacement direction. Displacement we represent with S. So they both are not in the same direction. So we can say the work done by the forklift is equal to 0. The work done at here equal to 0 because force and displacement are not in the same direction. Because force and displacement are not in the same direction. Now let's try one more example. Try to define work. You must be more careful about the direction of displacement and direction of force. So finally we can calculate work W equal to F times displacement T equal to 1000 times 0. Now here is the same situation. The work force times displacement, and how force and displacement are in the same direction. Suppose if this forklift is moving upward direction of displacement 1.5 meter. So this is the displacement 1.5 meter. So displacement D equal to 1.5 meter and force is given F equal to 100 Newton. Now one more thing we need to care about, what is that? Are they both in the same direction? Yes, in this case they both are in the same direction. If they both are in the same direction, we can easily calculate the work. Just multiply the work equal to force times distance. So you can multiply that 1000 newtons times 1.5. So here the work done equal to 1500 joules. So I hope you understand the difference between in these two cases. How the work is 0 in this case. In this case the work is 0 because the forklift is moving forward direction and force is applied in the perpendicular direction. So they both directions are different in this case. The displacement direction and force direction. So that's the reason the work done in this case equal to 0. Not only that, if you can take this early example, the man which is moving with carrying loads. So in this example also the work done by the person equal to 0 because he is applying force in this direction and the displacement is perpendicular. He is walking on the road, so he is moving forward. So this is displacement direction. So they both are not in the same direction. So we can say the work done by this person equal to 0. So this is how we define work in scientific. So work is nothing but product of force times displacement. And here we need to more careful about its directions, force direction, displacement direction. If force direction and displacement directions are perpendicular, it means they are not in 0. The work done equal to 0. But if the force direction and displacement direction, they both are in same direction. So in that case, we need to calculate work by applying a formula, force times displacement. So here sometimes distance, sometimes displacement are there, but every time the both are the same in the same situations because the distance and displacement are showing in the same direction. So we usually write only force times displacement. So wherever you can take that formula, just you write that force times displacement. So here displacement and force are in the same direction, so we can calculate work. Here the work done equal to 1500 joules. Yeah, this is all about work. So how we define work in generally and how we define work in physics or scientifically, it is entirely different. Finally, I can conclude by saying work formula, it's a product of force times displacement and work units are joules.